In this video, I'm going to do classwork 3.2, number 13. And so this one, a lot of times can confuse people because of going from a roller coaster where you're upside down to now a car where you are right side up. Okay, so it says you have a 1,000-kilogram sports car and it's moving at 20 meters per second, and it rounds the top of a hill that has a radius of 100 meters. Determine the normal force on the car, the normal force on a person in the car, and the speed at which the normal force equals 0. Okay, so if we can just look, remember in the last problem we did a roller coaster loop. Okay, on a roller coaster loop, up at the top of the track, okay, there is the cart, and you have force due to gravity acting down, and you have normal force acting down because the track is above you and pushing down on the car here. Okay, now in this problem we've got a hill or a car going up over the top of a hill, right? So you've got this scenario, okay, and we know that the radius here is 100 meters, okay, and if we put the car here, now at the very top we have normal force going up because the ground is pushing upwards on the car, and we've got gravitational force going down. So it's a little bit different of a scenario, okay? Now, it says that we want to know the normal force on the car, and the car is 1,000 kilograms, okay? So if we look at this, we want to take these forces and we want to subtract them from one another, okay? And I'm going to do Fg minus Fn equals mv squared over r. Okay? Now, the reason why I do Fg minus Fn instead of Fn minus Fg is because of the signs. Okay? Now, remember that the centripetal force is this, and it's pointing inwards. Okay, so this and gravity, so centripetal force and gravity have to have the same direction, and normal force is acting in the opposite direction. Okay, so here I've got Fg and mv squared over r are both positive, okay, even though they're down, and Fn is in the opposite direction. Now the other way I could have done it is I could have said, well, Fn minus Fg is equal to the opposite of mv squared over r, making the Fg negative and also making the centripetal force negative. Okay, so hopefully that makes sense. Okay, now if we do this problem, now all we have to do is really plug and chug, right? We've got Fg, which is mg, so 1,000 times 10 minus Fn is equal to mv squared over r. So 1,000 times 20 meters per second squared is what it said over 100. Okay, so let's see here, we get 1,000, let's do 20 squared times 1,000 divided by 100, and so I've got 4,000 over here, and then on the other side I'm going to have 10,000. So you get 10,000 minus Fn equals 4,000. So we can see that Fn in this case is equal to 6,000 newtons. Okay? Now let's think about that. Does this make sense? Remember that force normal is always your own personal perception of your weight. It's how hard you're pushing into the surface, and how hard you push into a surface kind of gives you this sense of your own weight. So as you're flying up and over the top of a hill, you can sort of like feel your butt sort of rise out of the seat, right? So you have, you should feel like you weigh less than you actually do, okay? So it makes sense that the normal force is 6,000 newtons. Now, if I would have accidentally inverted this, then my answer would have been 14,000 newtons, and we would have known for sure that couldn't be correct because of, using our common sense to say, does this answer make sense? Okay, now the next part says, well, what's the normal force of the person in the car? Okay, again, same problem, same setup. You're going to have Fg minus Fn equals mv squared over the r, and the only thing that's going to change this time is the mass. So we're going to have 70 times 10, or 700, minus the normal force will be equal to 70, still going 20 meters per second squared all over 100. So 20 squared times 70 this time, divided by 100. So 700 minus x is going to equal 280, right? So 700 minus normal force equals 280. So 700 minus 280, 420. So the normal force in that case would be 420 newtons. Okay? Now it says, what would the car's speed be if the normal force equals 0? Okay? So again, if we wanted to look up here, we can see that the sum of all forces equals mass times acceleration, or centripetal acceleration here. So what we're saying is, when you feel weightless, when your normal force is 0, when the perception of your weight is 0. So what would it have to be if this was 0? Okay, so in that case, I'll just write it over here, we would have Fg is equal to mv squared over r, where you have no normal force. Okay, and Fg is mg, so you'd have 1,000 times 10 equals 1,000, so our masses actually cancel, v squared over 100. Okay, so 100 times 10 is 1,000 equals v squared. Okay, and so then we'd have to take the square root of that, and I get that the velocity would have to be about 31.62 meters per second for you to feel absolutely weightless, or to feel like the normal force was 0.